In today's video, we are going to talk about linear momentum and angular momentum. First of all, let us discuss linear momentum. Any body moving in a straight line has linear momentum. Consider a body moving in a straight line. Let m be the mass of the body and v equals to velocity of the body, and body having linear motion. Body is moving in a particular direction. Then the product of mass and velocity is called linear momentum. Linear momentum is denoted by letter P. It is a vector quantity. In vector form, linear momentum is given by vector P equals to m multiplied by vector v. Rotating wheel has angular momentum. Angular momentum depends upon moment of inertia and angular velocity of the wheel. So, linear momentum is related to a body moving in a straight line, and a rotating body has angular momentum. First, let us understand the meaning of linear momentum. Consider a block of mass m. In figure 1, force applied on the block by single man. In figure 2, force is applied by two men. Let v1 be the velocity of the block when it is pushed by a single man. In this case, the momentum of the block v1 equals to m into v1, because the linear momentum is equals to multiplication of mass and velocity. Therefore, momentum p1 equals to m into v1. Now, when the block is being pushed by two men, the velocity of the block increases due to increased force acting on the block. In this case, the momentum of the block is again product of mass and velocity. Therefore, momentum of the block in second case P2 equals to m into v2. In figure 1, the block is moving with less velocity because force acting on it is less due to single man is working to push the block. Whereas in second case, the velocity attained by the block is more because two men are working on it to push the block. Momentum in first case P1 equals to m into v1, and linear momentum in second case P2 equals to m v2. So, linear momentum in figure 2 is more compared to linear momentum in figure 1. From above discussion, it is clear that when force acts on the body, linear momentum of the body changes. When single man is pushing the block moves slowly. But in between the journey, another man joins to push the block. Now, block moves faster. The velocity of the block changes as soon as the two men start pushing the block. So, initial momentum, that is starting momentum P1 equals to mv1, end momentum, that is final momentum P2 equals to mv2. Time taken to change from P1 to P2 is equals to t. Then rate of change of momentum P2 minus P1 upon t equals to mv2 minus mv1 upon t. Taking m common, so we get m multiplied by v2 minus v1 upon t, where v2 minus v1 upon t nothing but called acceleration of the block. It is denoted by a. Therefore, rate of change of momentum equals to mass multiplied by acceleration. So, m into a equals to P2 minus P1 upon t equals to force acting on the body. So, when force acts on a body, then linear momentum of the body changes. Now, let us discuss little about angular momentum. Angular momentum, is it a vector quantity or is it a scalar quantity? Don't confuse. Let us discuss. Whenever a body is rotating about a given axis, then direction of angular velocity is given by right hand rule. If curved fingers give direction of rotation, then direction of thumb gives direction of angular velocity. Angular momentum is denoted by L vector and it is a product of I and omega. Since omega is perpendicular to the body and it is along the axis of rotation, and L is a multiplication of I and omega, vector omega. So whenever you multiply a vector with a scalar, it is a vector as well as. So I omega is a vector quantity, even though I is a scalar value. So L vector is a vector and direction of L will equals to the direction of omega. Therefore, L is also a vector quantity. When the body performing rotational motion, the particle present on the body perform the circular motion. Let us consider one of the particle with mass m. Now, linear momentum of this particle is nothing but given by vector p equals to m into vector v. That is a linear momentum. And the angular momentum of the particle is given by vector r cross vector p. That is equals to r p sin theta, where theta equals to 90 degrees. Therefore, vector L. Now, when you remove the vector RHS, you have to remove the vector symbol in the left also. So that becomes the magnitude of L. So L equals to r p sin theta, where theta equals to 90 degree. Therefore, sin 90 equals to 1. Can you guess why theta equals to 90 degrees? Please write down your answer in the comment box. But P equals to M into V. Therefore, L becomes L equals to MVR. It can also be written as V equals to R omega. Therefore, M R omega multiplied R equals to M R square omega. So L equals to M omega R square.